Impact of solid waste disposal on quality of groundwater around different landfill sites of Nizamabad city, Telangana state. Abstract. One of the worldwide biggest challenges is solid waste management. Landfilling is the simple and common method of disposing solid waste ever observed in developing countries. The landfill leachates loaded with pollutants percolates into water bodies present around a landfill sites results in pollution of groundwater. An attempt is made to study the impact of landfills on groundwater quality present around the landfills of Nizamabad city, and for proper interpretation the results also compared with the results of assessment of water samples from Alwal landfill located in Greater Hyderabad, where an integrated solid waste management is undertaken. The water samples collected from various radial distances from the landfill site. Results of the study clearly indicate that the groundwater quality is deteriorated badly and regular monitoring of groundwater quality is needed. It also recommends need of site-specific policies on groundwater pollution control for Nizamabad landfill sites. Keywords: landfills, solid waste, pollution, leachate, groundwater, and WQI, Water Quality Index. Introduction. Disposing of solid waste at open low-lying areas in unscientific manner leads to pollution of air, water, and soil, and also results in adverse effects on public health living nearby areas. 7-9. Deterioration of groundwater quality due to percolation of leachate generated from landfill sites is predominantly observed in many developing countries like in India. 10-13. It is reported that most of the landfills are unlined and without leachate collection system. The rate of deterioration of quality of groundwater resources near the landfill sites is need of urgent regular monitoring measures in many cities and towns of the country. 14. The susceptibility of an aquifer to pollution from landfill leachate is highly dependent on number of factors like location of dumping site, composition of waste dumped, toxicity of leachate, depth and flow of water table and type of landfill. 15, 16. Groundwater is the most common source of water supply in both urban and rural regions of developing countries, and pollution of groundwater is potential threat to environment and public health. 14, 17. The impact of leachate on groundwater has been reported in many studies, 18-20, with the common conclusion of presence of high level of organic and inorganic pollution due to percolation of leachate. A study conducted 15 reported high values of pH, nitrate, and BOD in groundwater sample collected from the vicinity area of Malang landfill. A research, 21, conducted in metropolitan city of Delhi, reported high levels of trace elements like K+, Cl and NH4+. Studies, 22, 23, have investigated the leachate composition generated from dumping sites and related it with groundwater quality of nearby areas. An improper solid waste management system and absence of properly designed solid waste disposal mechanisms, landfills with growing urbanization, industrialization, and population explosion has led to environmental pollution. The contamination of groundwater is a potential environmental problem and needs to be addressed. Hence, an efficient method has been carried out to monitor the groundwater quality index around municipal solid waste landfill sites of Nizamabad city. The quality of the groundwater has been studied. The waste generated in Nizamabad is dumped in open dumping sites. Residential and agricultural land is located in the vicinity of the dumping sites of 3 selected regions of city with seasonal rivulets flowing nearby the dump sites. Although the municipal corporations of the city are providing water supply, but around 30% residents are still using groundwater supplies like borewells for daily needs. Percolation of leachate from these open dumping sites poses threat to groundwater sources, so a study was planned to evaluate the effect of dumping sites on the groundwater resources in the vicinity areas of dumping sites of Dharmaram, Nagaram, Nehru respectively. The study also reported the WQI, calculated over a period of 2 seasons, dry and wet, from all the 3 regions of study sites of Nizamabad city to cover major city topographically, for determining the impact of leachate percolation on the groundwater quality. Materials and methods. Study area. Nizamabad city is the headquarters of the Nizamabad district, Telangana state. It is located at the intersection of longitude of 18.672 degrees north 78.094 degrees east and spread over an area of about 40 square kilometers to determine the possible groundwater contamination due to percolation of leachate from selected solid waste landfill sites. The groundwater samples were collected from the nearby selected landfill sites Idharmaram, Nagara, Nehru-Nagar of Nizamabad city during dry and wet seasons of the monitoring campaign. The groundwater samples were collected from the borewell and other nearby submersibles close to the solid waste dumping sites at 5 different downstream locations, 1 kilometer, 2 kilometers, 3 kilometers, 4 kilometers, and 5 kilometers, from the MSW dumping sites. Figure 3, A, B, C, and D, shows the aerial view of the studied areas with groundwater sampling points. A total of 30 samples, n equals 5 for each site, were collected for the study purpose during entire 2 sampling periods, dry and wet, from 3 study sites of Nizamabad, and 10 samples were used from Alwal region of Hyderabad during entire 2 seasonal campaign. Separate analysis was carried out for the samples collected from different distances of study locations. The analysis of groundwater samples were carried out as per the standard procedures. Analytical methodology. According to WHO organization, about 80% of all the diseases in human beings are caused by water. Once the groundwater is contaminated, its quality cannot be re-established easily, and to devise ways and means to protect it. Groundwater quality helps us understand the hydrogeologic system, flow dynamics, and groundwater contamination. Groundwater samples were determined for physicochemical parameters according to the standards APHA and BIS methods, 29, 30. All the samples in the experimental work were analyzed for physicochemical parameters like pH, electrical conductivity, EC, total dissolved solids, TDS, chemical oxygen demand, COD, biological oxygen demand, BOD, total alkalinity, Ta, total hardness, TH, chloride, Cl, sulfate, SO4-2, phosphate, PO4-3, calcium, Ca+2, magnesium, Mg+2, ammoniacal nitrogen, NH4+N, fluoride, F, nitrate, NO3, sodium, Na+, and potassium, K+. Water Quality Index. Water Quality Index, WQI, is a method of rating of existing water quality status in a single expression which is helpful for selection of treatment techniques. 31. WQI provides information about the water quality in a single value. WQI utilizes the water quality data and helps in modification of the policies formulated by the environmental agencies. 32. It represents the assessment of water quality through determination of physicochemical and biological parameters of groundwater. 33. WQI was initially developed by Horton, 34, 35, and after that concept has been modified by many scientists and researchers. 34 to 37. A general approach for determination of WQI includes parameter selection, wherein these parameters are selected based upon their impact on water quality. Once the parameters are fixed, determination of sub-indices of these parameters is quantified, which are finally aggregated using an aggregate indexing method by means of different mathematical expressions. 24, 37. Water Quality Index BIS 10500. Determination of WQI as based on the BIS 10500 standards was determined by assigning weights, WI, according to the relative importance of each chemical parameter for drinking purposes, and has been summarized 12. The parameters like chloride, nitrate, total solids, ammoniacal nitrogen, sulfate, fluorides, and electrical conductivity has been assigned maximum weightage of 5 because of their high significance in maintaining quality of groundwater. 61. Other determined parameters like calcium, magnesium, total hardness, and total alkalinity were assigned weight between 1 and 5 depending on their importance in water quality assessment. The relative weight, WI, is computed using following equation. Results and discussions. The physicochemical characteristics of the groundwater samples collected from Dharmaram, Nagaram, and Nehru-Nagar of Nizamabad and Alwal region of Hyderabad are described in Table 2. Obtained results were also compared to the WHO and BIS standards for drinking water. The results of all the parameters are symbolized as S1 and S2 for Dharmaram, Nagaram, Nehru-Nagar, and Alwal, Hyderabad for dry and wet seasons respectively. Physicochemical parameters. Water Quality Index, WQI. WQI is one of the most effective tools to provide feedback on the quality of water to the policymakers and environmentalists by giving a single value. In the present study, WQI determined on the BIS 10,500 standards and values for all the 3 study sites of Nizamabad respectively were calculated using equation for standards for drinking water purposes as recommended by BIS 10,500. The values of WQI obtained using the methodology based on BIS 10,500 have been summarized in Table 3 and the classification of water quality have been summarized in Table 4. Conclusion and discussion. It was observed from Table 4 that the groundwater quality in almost all study sites of Nizamabad within a 2 km vicinity of the dump site experiences poor quality of groundwater for drinking purpose, without any exception during entire seasonal monitoring campaign. Beyond 2 km radius vicinity of any dumping site of Nizamabad that are located in Dharmaram, Nagaram, and Nehru-Nagar experienced a good water quality value. The poor quality of groundwater in Dharmaram is primarily because having more dense small and medium-scale industries. The primary reason behind poor water quality in Nagaram might be due to high dense population and highest socio-economic status among all areas of Nizamabad city. That could be result in disposal of high amount solid waste into the environment. Lack of proper solid waste management systems could be considered as primary reasons for poor water quality on Nehru-Nagar. The cumulative average of all distance collection points of any of the study site lies under the category of good water quality, as shown in Table 3. Seasonal variation showed that the overall dry seasonal water quality was superior to wet season due to increased chances of leachate percolation into layers of soil associated with dumping sites, which was resultant of high moisture content in the environment. So dry seasonal water quality index of all study sites including Alwal region of Hyderabad was observed to be superior when compared to wet seasonal water quality index. One important note has been observed from the results that with increase in downstream distance, the quality of groundwater improved. Similarly, it was observed from that the overall quality of groundwater was classified as good for all study sites including the Alwal region of Hyderabad. The WQI results revealed that the groundwater samples from the nearby location to the dumping sites are affected due to leaching of ions from the leachate. We made an important observation from the results that relative water quality of Alwal Hyderabad is good when compared to other 3 study sites of Nizamabad. This observation could take a positive important note to understand implementation procedures towards sustainable development of various solid waste management practices for Nizamabad city. Acknowledgements. One of the authors, Vasavi Neeli, is grateful to staff members of the Department of Telangana University for their continuous support during the period of study and also thankful for the constructive comments of the reviewers towards this article during its review process.